Hey guys, my name is Alex, or as some of you have been calling me, Slothman. I was doing some searching around on the internet the other day trying to find build recommendations on budget-friendly VR gaming computers because I wanted to be able to use my Oculus in the living room without having to move my main gaming computer out there every time I wanted to play VR games with friends. If you've done your own research on this topic like I have, you'll find videos like Linus's video on building a cheap budget VR computer that traditionally cost you anywhere from $800 to $1,000. Well, I wanted to see if I could do it cheaper. Today I'm going to show you how you can buy a VR-capable computer that handles any title you can throw at it for under $300. It won't require a whole lot of work to get up and running, and it will be capable of playing some of the most demanding VR games using high and sometimes even ultra graphics settings. Today I'll show you that not only can our build compete with Linus's budget VR computer, but it also holds up fairly well against an even more expensive i7-6700K to provide a great VR gaming experience while only costing you between $230 to $300 fully built. This is the Dell Precision T3600 series desktop. These computers came into the world with the intended purpose of being great at CAD, advanced engineering, digital content creation, and other engineering type workloads. They make great streaming and gaming computers, are great at compute workloads like photo or video editing, and can even double as a home media server using Plex or Ombi, but we'll get into that in another video. These computers can be found on eBay for anywhere from $90 to $120, and if you get lucky, it will come with a Western Digital 500GB black drive. While you can upgrade to an SSD as I did, it won't affect your FPS in games. However, it will improve loading times. There is also a big brother to the T3600, the T3610. The T3610 comes with a few extra USB 3.0 ports, more PCIe lanes to the PCIe risers, a bigger 685 watt power supply, and it adds support for the E5 1600V2 and E5 2600V2 family CPUs. These are among some of the advantages of choosing a T3610 over a T3600. The price of the T3610, however, is higher. Expect to spend anywhere from $200 to $250 shipped for one of these. I will say the performance difference between the two is somewhat negligible, as there are great CPU options for either. So which CPU will keep the price down while not sacrificing too much performance? Well, I tested quite a few Xeon options, and a lot of the T3600 desktops on eBay come pre-built with an E5 1620 CPU. These are fairly decent processors and will do okay in video games and VR, but if you want an upgraded CPU that can be had for a decent price, the E5 2687W is a great option. It has 16 cores with hyperthreading enabled, and its multi-core performance can surpass the i7-6700K in Geekbench, as you can see here. These E5 2687W CPUs can sometimes be found on eBay and Mercury for between $60 to $90. I picked mine up for $80. If you've never changed out a processor before, don't worry, it's very easy. Here is a video on how to install a CPU in this exact computer. It's literally 4 screws and some thermal compound. And here is a video of me installing a GPU into the T3600. These are all of the technical skills required to have this machine upgraded and up and running in under 10 minutes. If you go with the T3610, it likely came with an E5 1620V2 CPU, which is a bit slower than the E5 2687W. Other upgrade options for the T3610 you should look at include the E5 1650V2 or E5 1660V2 processors. The E5 1650 V2s can be found on eBay for about $80, while the 1660 V2s are a bit more expensive, coming in between $180 and $200. Here is the breakdown and total cost of the T3600 we used making this video, along with some other options. Keep in mind the most important component is the GPU. You will want to spend more on your GPU than what you spend on the entire system. This system can be built for as little as $226, with our recommended build coming in at around $300. I will show you how powerful this system is with some of these GPUs today, and you can decide what your wallet can handle. If you can afford a few extra dollars, my recommendation to get the best bang for your buck would be to build your T3600 in this configuration. This configuration includes an E5 2687W, at least 8GB of DDR3 1600 MHz memory, and the NVIDIA GTX 980. The total price of our system in this configuration is around $280, and depending on what your T3600 comes with, you might need to purchase an extra PCIe 8-pin to dual 8-pin adapter like this one shown here. You can find this on Amazon for $13, and there's a link in the description. This adapter will help you power any aftermarket GPU you add. Said and done, after you sell your stock CPU like I did, you would have only spent a total of $294 on the entire system. Now, with all of that said, if you can afford an extra $85, I recommend purchasing a GTX 980 Ti or GTX 1070. You can pick these up on eBay right now for between $240 to $250. You don't have to buy one of these cards, but the VR experience is a bit better, and I think that makes it worth the extra $85. The 980 Ti is extremely undervalued on eBay. If you opt for a GTX 980 Ti instead of the GTX 980, you will see a 10 to 20% FPS improvement in some flat games, and it also helps a lot in VR, as you will see in the VR benchmarks a bit later. I noticed the smoothest gameplay in VR games while running the 980 Ti, which was no surprise. In some games, with graphics settings set to high or ultra, the 980 Ti had a better chance of keeping ASW disabled for a true 90 FPS experience. More on that later as well. The GTX 1070 performs pretty close to the 980 Ti, and you can't really go wrong with either card. All of that having been said, the GTX 980 is the card I focused on with my tests, and it did great in every game I tested it with. It was the all-around best bang for your buck. If you want to go cheap on this build, but still have great performance without having to sacrifice graphics quality, the GTX 980 is the way to go. So let's start with synthetic VR benchmarks. Here are the VRMARK Orange Room and Unigine VR performance test results. You can see the GTX 980 takes the lead here, and it has a slight edge when compared to the 1060. You can't go wrong with any of these GPUs. They all did quite well in my testing, as you can see from these benchmark results. When the GTX 980 is overclocked, it performs very well, and the overclocking headroom on a GTX 980 makes it the better choice when compared to the GTX 1060. The GTX 980 Ti leaves the competition in the dust when it comes to synthetic benchmarks. From SteamVR performance or VRMARK Orange Room benchmarks to Unigine VR synthetic benchmarks, making it a great upgrade option if you have a few extra dollars to throw around. Enough with synthetic benchmarks. What about real VR games? Let's start with Eternity Warriors VR. We ran these tests with all the graphics settings set to high and HDR turned on. The results are fairly consistent across the board. On paper, it didn't really seem to make a difference which GPU you go with. That said, an overclocked GTX 980 or GTX 980 Ti yielded a visually smoother experience with a few extra FPS to boot, this ultimately being due to less FPS dips. The next game we tested was Killing Floor Incursion. Once again, these tests were run with all the settings on high and 120% resolution. As you can see, the average FPS with all cards tested was fairly equal. All the cards I tested with had the game running very smoothly and kept it very playable. You wouldn't be disappointed regardless of which card you chose in this title. RipcoilVR is up next. With all settings on high and 100% resolution, the story was pretty much the same. While frame rate stayed at 90 FPS, the 1% lows or frame rate dips stayed pretty consistent here as well. Marvel Powers United VR was a slightly different story, however. With graphics set to high and the resolution scaling at 100%, the GTX 980 Ti kept ASW disabled and kept the average frame rate at 87 FPS. While it looks like it won by leaps and bounds compared to the rest of the pack, this is a bit deceiving, as the other cards didn't perform well enough for ASW to be disabled, keeping the frame rate locked at 45 FPS. The oversimplified version of ASW works like this. If the machine can't keep a consistent 75 FPS, ASW gets enabled and the frame rate gets locked at 45 FPS. I had to lower the quality to medium to get the GTX 980 and 1060 to hold a constant 90 FPS. The difference in quality wasn't that noticeable from medium to high, so this wasn't a big deal at all. If you want to read more about ASW, please find the link in the description below this video. All things being equal, I think the experience with ASW disabled is always better, and when it is enabled, it is perceivable despite what you may read online or from vendors. It does feel and look a bit smoother at a true 90 FPS versus 45 PS with ASW enabled. Action scenes and fast motion being the most noticeable and frustrating consequence of ASW being automatically enabled. But it might not be something you care about. Ultimately, the GPU you choose will make the biggest impact on what frame rates you see in VR. With ASW as an option, however, that 90 FPS target isn't a total deal breaker. Marvel being the perfect example of a game requiring lower than high or ultra graphics quality to maintain 90 FPS for all but the 980 Ti. But the game was still very playable at 45 FPS thanks to ASW. As you could see from our tests, our T3600 gaming rig was pretty comparable when matched up against the 6700K in VR games. It played all the VR titles we tested with on high quality except Marvel VR and did so smoothly with no noticeable jitter or stuttering, all while maintaining close to 90 FPS in almost every game tested. If you keep resolution scaling, or as some games call it, adaptive resolution at 100%, you will get a true 90 FPS with this gaming rig in most games with your graphics set to high. In the rare cases where you have to lower the quality, medium will generally net you the 90 FPS required for the best experience. With our system, most games will maintain 90 frames per second, providing you a very smooth experience because the Oculus Rift, HTC Vive, and Vive Pro are all locked at a 90 Hz refresh rate, and because they all have VSync enabled, 90 FPS is the cap, which is totally achievable with our sub $300 T3600 gaming computer. There is benefit to having a computer capable of above 90 frames per second. That benefit lies in consistent frame rates. A 90 FPS average doesn't tell you the full story. The 1% low dips you may encounter, as well as the sub 1% dips, draw a complete picture with regards to performance. Most games look like this. With the average frame rates hovering around 90 frames per second, the dips can still drop all the way down to 45 FPS or lower. Here are some more titles that really highlight just how our T3600 performs. And no, we didn't cherry pick titles. I tried to find popular games and threw in some demanding VR titles as well to get as accurate of a picture with regards to performance for you as possible. We have finally reached our TLDW summary. Both the GTX 1060 and GTX 980 perform very well in the T3600 when paired with the E5 2687W CPU. For a total cost of $294, this computer is quite capable and played every VR title I threw at it with ease, even with the graphics settings set to high. To summarize, the T3600 can be built with its stock 425 watt power supply, which should be adequate if you run the GTX 1060, 1070, or GTX 980. For reference and reassurance purposes, when I tested the GTX 980 at 99% utilization and the CPU, the E5 2687W, at 100% utilization, the system drew a total of 360 watts. So the stock 425 watt power supply should be fine in most cases. That said, if you go with the GTX 980 Ti, you should upgrade the power supply, as this is a very power-hungry GPU. The 685 watt power supply can be found on eBay for $50, while the 1300 watt power supply can be found for $60 shipped. I purchased both for testing, and they both ran the 980 Ti, but the 1300 watt power supply option provides quite a bit of headroom, which makes it the better choice since it's only $10 more. Let's go over some of the fine details to help you on your journey should you choose to purchase this awesome gaming computer. The T3600 has a modular power supply, and the power supply backplane has one 8-pin connector on it as shown here. This adapter, which I mentioned earlier in the video, allows you to power an aftermarket GPU from the backplane of the power supply. There is ample room to install any GPU you want in this case. Here is some footage of how different graphics cards fit in this case. From a small GTX 1060 to the 980 Ti, most cards will fit in this case without any problems. Keep in mind the side panel, which has a bit of metal that could get in the way of half-height card power connectors. You can remove this, but it's probably best to purchase full-length GPUs, assuming they have additional power requirements. There are, of course, other GPU options you can pair with this computer, from the AMD RX 480 to the RX 580 or Vega 56, Vega 64. Any of these GPUs will perform very well on this computer and should all play VR titles as well. I'm not specifically saying you have to build this with an NVIDIA GPU, but these were the cards I had at my disposal for testing purposes, and the extra power draw from most AMD cards would likely mean you would want to upgrade the 425 watt power supply if going this route, which is an extra $50 to $60 that you simply just don't have to spend if you're using the GTX 1060, 1070, or GTX 980. In our next video, I will be benchmarking some non-VR flat games, so stay tuned. Thank you for watching. Please like and subscribe as it really helps our channel grow. You can find us on our website where a full technical article will be written up in the coming days for this video at slothtech.tv.com. And if you have any titles you'd like benchmarked in a follow-up video or flat games in our upcoming video, please comment below.